Hello, welcome to, I guess this is a project brief. I think I made the title BOINC Radio episode number 111, so whoops. But radio episode number
Same thing. Come on.
111. We're doing a project brief on WANLess, that magical project that just keeps finding numbers many times. And of course, we always have some news coming from BOINC. I think just project news, general news about BOINC release. And you know what, Delta? I'm jumping in. I'm cutting off your beverage. Let's talk about the BOINC release first. BOINC update 7.22.1 is ready for testing on Windows, Mac, and Android. There's no Linux release yet, but it's Vitaly and the BOINC devs and maintenance crew would love your help testing it out, submitting bugs, and getting involved in any way you can. So feel free to jump into the announcements channel here on the BOINC Network Discord server, or follow Vitaly on Twitter if you have Twitter, which you already should. If you have Twitter, you should be following them anyway. Get the update, test it out, submit bugs as you find them. Do the thing that you do. All right, that's it. Now we can get to your beverage.
Finally, okay. So, you know how I've been going through the Arizona tea. I'm going through a little Arizona tea phase, right?
Mm-hmm.
Well, there's one problem with that. When I was in Woolies the other day, they have a new flavor of milk. So I just had to buy it. You got a bit of connection issues there, Jeringo.
All right, I was saying it's just so rare to hear that sentence before. A new flavor of milk.
There is a new flavor of milk. And basically you need to get them before they go out of date. So although there were two flavors that I saw, you might only see me review one because I have a feeling they're just going to stock one. They're just going to stock them once and then never stock them again. Okay. So I am drinking the Brecker Chupa Chups Choco Vanilla flavored milk. If the blurring doesn't want to sense the brand. So yes, I am drinking the official Chupa Chup milk.
I mean, honestly, that sounds all right. Chocolate vanilla milk.
Yeah, and
good.
it has a similar blurb to Oak, and this is not made by the Oak company. By the way, it's made by another company called Brecker. How do you capture the flavor of fun and put it in a carton? Who knows, but we did. Open this delicious Brecker flavor and enjoy a mouthful of fun. Seems kind of generic and boring for a little blurb on the side. But let's give it a taste. Okay, so it basically just tastes like chocolate milk, but you get kind of like this like really strong vanilla kind of like aftertaste. Yeah, like it just literally tastes like chocolate milk. It's not really that special.
It's the
If I were to
most
rank it,
you've ever done.
honestly, yeah, like there is literally nothing special about this. The blurb is boring. The flavor is boring. It's yeah, like I mean,
but it's still
the sugar
chocolate milk,
content
right? You
good?
can't go wrong with it. Yes,
It's
900
got the same
grams.
it's got it's got the same amount of sugar as the Oak. Oh, hold on, that's probably why it tastes kind of a bit strange. It uses pasteurized, homogenized, reduced fat flavored milk. So it contains at least 40% less fat than regular full cream milk. That's why it did taste a tiny bit watery. Yeah, so yeah, this is probably like really boring. If I were to rank it with the other Oak milks, I'd probably rank it below banana milk.
That's, I mean, not shocking, but it's not the worst, right? It's just freaking chocolate milk. Water and chocolate milk.
Yeah, I guess.
All right. Well, what a review. My heart is racing. My adrenaline is running. This has been super exciting. banana milk beats chocolate milk.
Yeah, the
Move
Chupa
on.
Chups.
So there is some news you wanted to share, yes, from various BOINC projects.
Yep. So one from TN Grid, because they are probably bringing back online one of their old projects. So if you crunched TN Grid a while ago, and we're talking like a long time ago, they had a project called Vitis vinifera, which I think had to do with like the genome of some plants. And they said that they're excited to announce that there's a bigger data set for Vitis vinifera transcriptomic data. It is now available for open gene expansion. So hopefully we'll see with TN Grid in probably the coming weeks, or maybe, worst case a month, we should see them release some work units for this. I just checked their status page. They've got no work units ready for processing yet, but hopefully they'll have some soon. So keep an eye out for TN Grid.
Very cool.
Another quick one. Okay, just an announcement for the BOINC Pentathlon 2023. It is currently running. We're kind of in the middle of it at the moment. All there is on the Numberfields forum is just an announcement. But yeah, good luck to everyone running in the BOINC Pentathlon 2023. And looks like Yo-Yo at Home found an ECM factor, 77-digit prime factor, and is the 4th largest ever. Wow. There is a 1 in 28.3 million chance of finding this particular factor. So congratulations on the user Favebook for finding the 77-digit prime factor.
Cool. Do they get a certificate or anything? Is that one of those projects?
They get an honorable mention on the Yo-Yo at Home forums, and they get an honorable mention here. So I think that's
that gives me a flashback to Cruncher of the Week. The Rig of the Weeks. That's what it was.
Hold on. Do you often go on to like different BOINC projects and see like the user of the day?
I do not.
Yeah, next time you go onto a BOINC project, probably one that's not got like a custom interface like Einstein at Home or World Community Grid, go onto one like I think Yo-Yo at Home or TN Grid. They'll have like a little banner at the top that says user of the day, and you get some kind of funny user profiles that come up.
I will do that.
Yeah. Yeah, let's move on to the project brief if there's nothing else that you'd like to talk about, Jeringo.
No, I got nothing. Let's do it. Tell me about numbers, finding numbers.
Sweet. Okay, so I've done this before, and I'm doing it again. We're going to talk about WANLess. So a lot of people here will probably know WANLess as that project that keeps pumping out the announcements that say 12-digit factor found 200,000 times or something crazy like that. So I want to go through it again and explain a bit about it because I know a little bit more information about it now. So one thing I want to ask you, Jeringo, is have you ever thought about what you would do if you found a 12-digit number?
What do you mean by find a 12-digit number? Like just come across it?
I'll be honest with you. I decided to play around with ChatGPT for this one. I asked it to generate a question that I can ask you that's funny and related to the WANLess project, and that's what it produced.
You didn't prompt it at all to explain what WANLess was, or?
I gave it a little bit of a description of what it was.
Okay.
So yeah, what would you do if you found a 12-digit number?
Cut it down to size, man. It only deserves 11 digits.
Well, if I were to find a 12-digit number, I'd probably post it on Twitter.
Okay. Is it exactly? Well, it's 12 digits. I was going to say, is it 140 characters? But I don't even think that's a Twitter thing anymore.
Not if you have like the Twitter Blue or whatever it's called. I don't think.
What a world we live in. But yeah,
But
I'd
anyway.
make it 11 digits.
Okay, so yeah, today we're talking about WANLess, or it's also known as like WEP M+2, I think it's called. And yeah, it's a UK-based project. It's a number theory project, so it mainly just crunches numbers and deals with just number theory and mathematics, like a lot of other BOINC projects. And it's been crunching numbers since 2006, apparently, according to BOINC Synergy. Now, WANLess is a bit interesting because it uses it mainly concerns itself with two sort of concepts. One is Mersenne +2 numbers, and the other one is the WEP algorithm. So we'll talk about the WEP algorithm a bit later, but Mersenne +2 numbers are kind of interesting. So what a Mersenne prime is a prime in the form of 2 to the power of x, all of that minus 1. Very simple algorithm, and we want to see how many prime numbers are in that sort of range. Now, some of these prime numbers can get like really huge. With computers that we use nowadays, they go up to 2 to the power 64 bits. So sorry, they use 64 bits, which means that we have 2 to the power 64 possibilities in representing numbers, which is a pretty huge number if you go and type in 2 to the power 64 into your calculator. But what WANLess works with is what's called P2203. Now, this is a Mersenne prime that's 2 to the power of 2,203. And that's a really big number. You don't really want to punch that into your calculator because I'm pretty sure it will crash your calculator. So basically what they're trying to do is they're trying to find factors of this prime number, but not exactly. What they do is they take the prime number, add 2 to it, and then they try and find the factors. So if we add 2 to this number, according to what we've learned so far, the number that results is not a prime number. So whenever you see in the announcements of the WANLess forum that they found a 12-digit factor X amount of times, they have found a factor of this P2203 +2. Now, this is pretty insane. So if you think about 12 digits, that's like more than what? That's 3, 6. Yeah, that's more than a million. That's more than a billion. It's more than a trillion, I think, as well. And these numbers have to be multiplied by other numbers to get this hypermassive number, 2 to the power of 2,203. So there's some insane mathematics that goes on behind the scenes here and some really big numbers. Now, another thing with the WANLess project is they're focusing on numbers and factors with the WEP algorithm. So as far as I know, and I should probably also double check this as well, the WEP algorithm that they refer to is actually the wired equivalent privacy, which you might have heard or might have seen when you're setting up like a Wi-Fi router or something like that. Now, with the WEP algorithm, it's generally insecure because there's a much more secure algorithm that we use nowadays, and you probably see most commonly with Wi-Fi routers, WPA2. So the WEP algorithm is known to be quite insecure, and happily enough, there's an attack called the Cafe Latte attack for the WEP algorithm. Mainly, and the reason why it's called this is because you can be sitting in a cafe sipping a latte and obtain a WEP key in a matter of minutes, pretty much. That's how broken this algorithm is. And so what we're doing with this project here, WANLess, is we're trying to also investigate the algorithm of WEP and see how it changes when the factors change. So there is a significance to each of the forum announcements saying that we found this 12-digit number X amount of times, because that X amount of times is going to be used as statistics to see how more efficient or less efficient the WEP algorithm is when we reach that next set of digits for the factors. So when we see our first 13-digit factor, we want to investigate how much harder or how much easier, or maybe there is no difference at all, in actually figuring out these factors. So that said, what will happen when we find the 13-digit factor? I think we'll probably have a pizza party. Maybe bring a bit of champagne. And just for scale here, we gotta get through all of the 12-digit factors first before we can get to the 13-digit ones. And that involves counting through and sifting through basically everything in the 12-digit number space, pretty much, and then factoring that massive number. We have algorithms to do it, and yeah, that's pretty much what WANLess implements. But with regards to the 13-digit factor, we also might see a publication. If we find some interesting things regarding the WEP algorithm as we continue and go into the 13-digit factor territory, we might actually see a publication from this project. On a small side note, if you do want to see publications for other BOINC projects, I know that BOINC Synergy has a projects page that you can go and search up, and it has a nice, neat list of publications tied to each BOINC project. So if you want to go and check out some of the actual science that came out of these BOINC projects, go ahead and check boincsynergy.ca. At least I'm pretty sure that's what the URL is. Now, let's get on to a bit of a controversial topic. So the usefulness of this project. It is a math project. It's a number project. And what we're trying to do is we're trying to find factors of a big, massive number. Now, people will argue whether or not this project is worthwhile to run because it might not actually contribute anything to science. But the way I see it in the BOINC ecosystem is really it doesn't matter if a project does something useful for science or not. The key thing is that it gets the community together and engaged, and it gets people engaged as well. So the one great thing about the WANLess project is that the announcements get people talking. Like, it's the reason why we're hosting this episode here. And it's the reason why I'm talking to you about the WEP algorithm and mercenary primes and all this crazy stuff here. So look, if the project does find that 13-digit factor, it could have some implications in number theory, but we don't know. It could go anywhere, really. If you want to crunch a project, it has all right hardware support. It supports Linux, Mac OS, and Linux on ARM devices, although I didn't see any applications for Windows. So Windows users, beware. Might not be able to crunch this one. Also, I'm not sure if I saw GPU apps on there. So I'm pretty sure they don't use a GPU app. Now, yeah, that pretty much concludes the project brief on WANLess. Anyone have any questions or, yeah, anything to say about WANLess, Jenga?
There we go. Yeah, it's very cool. It's like literally, so WEP, the wireless encryption thing uses the same principle of this project. Like it's a direct correlation of a math project to a practical.
I'm pretty sure, unless they're talking about some other WEP algorithm. I just did a quick double check on the Wikipedia article to see if there's any if it uses prime numbers or mercenary primes on the Wikipedia. I couldn't find anything regarding that, so I can only assume.
That's pretty interesting, though.
I'm pretty sure there's no other WEP algorithm. So unless someone else can point it out. So
I definitely can't. I'll take your word for it. If anyone shoots me because of it, I'll blame you.
Yeah. So yeah, I'll be the target.
Okay.
But yeah, the WEP algorithm is really insecure. You should, if you're ever setting up a Wi-Fi router, do not select WEP. Always select WPA2, because that way you're just a lot more safer.
Noted. That's really it. Thanks for explaining the project again. That's all I can think of.
Yeah,
and I'll still make fun of it as something I don't understand what they're saying, because really, I don't.
They're just trying to find the factors, Jaringo. They're factorizing this massive number.
Yeah. Why do they have to say it's been found so many times?
They're creating a data set of how long it took and how many times it was found, so they can compare that to when they start finding 13-digit primes. Oh, sorry, 13-digit factors.
Okay. All right.
Yeah.
That's why they
collect the amount of times.
So how do they? I guess how does the project work? There's a question for you. Are they sending the same work units out thousands of times just to get?
I'm gonna take a look. Let's give a quick look. So what I'm gonna do is I don't have an account. If I go to server status, I don't know.
Would you say you're WANLess?
Fine. No. Statistics, question answers. Nah, I'm unable to see just random tasks. Okay, but what I would do to probably check to see exactly how it works is I'd go into my tasks on the actual BOINC project website. Then I'd go in and see how many wingman validations it needs. And that'll probably tell us kind of how the project runs. Unless maybe they find that factor multiple times over and over and over again in the same work unit, which I don't know why they do that. But anyway, we should probably wrap it up here.
I believe so. Bye.
See you later. Thanks for watching.
Is that a good wrap up?